Thanks for confirming that. So we're moving on to a new topic today, guys. Now, this slide here is just trying to show you an idea of what we're actually trying to do, and then we sort of move on to the algebra behind it. So the idea is here, we've got two straight lines, okay? So we've got this straight line here, which is the one with the red dots on it, which is y equals 3x plus 2. And obviously that's a line that just comprises loads and loads of coordinates, loads of points all just sitting really close together, and that's what forms a straight line. Now this is the second straight line here, this one with the light blue dots, y equals minus 2x plus 3. And again, that line comprises loads and loads, billions of points all touching each other to the point that it just creates a straight line. Now, where those two lines intersect, there's one coordinate, there's one point which is on both the red and the blue lines. And our job is to work out what that coordinate is. Okay, so that coordinate is going to have both an x value and it will have a y value. And our job is to work out both the x value and the y value. Okay, so how do we do that? So here's an example of a question. So this first one, so there's our two lines. Okay, so just going back to that previous slide, there's your line number 1, there's your line number 2. So the first line is 3x plus y equals 7, and our second line is 2x plus y equaling 6. And we've got to go and do some algebra so that we can figure out what that coordinate is where they cross, what the x value is and the y value. Now, in time, and it won't take you long, I expect, you'll just know automatically whether you have to add or subtract the equations from each other. Now, that's the key opening learning point. Do I have to add these equations together, or do I have to subtract them? So I'm just going to do both, and just so you can see that whilst they're both mathematically correct, one of them is helpful, the other isn't. So let's go and say, for example, that we chose to add these equations together. So we're going to add the x's together, we're going to add the y's together, and we're going to add the numbers together. Okay, and that will still make it equal because these sides are still equal, these sides are still equal. So we're going to start off by adding the 3x and the 2x, and that gives us 5x. We're then going to add the y to the y, giving us 2y, and we're going to add the 7 to the 6, giving us 13. Now that's all mathematically correct, but it hasn't got us anywhere. We haven't what's called eliminated either x or y. So we're still none the wiser. We still can't work out what the x value is or the y value. So that's mathematically correct, but it hasn't been helpful. However, let's go and say we subtracted one of the equations from the other. So put the bigger one on top, and then we're going to subtract the other one. Now, 3x take away 2x is x, 1x, x. And y take away y is a big fat nothing. And that's what we're looking to try and do. We've eliminated y. Y has disappeared. And that is our goal. Now, carrying on with the taking away, 7 take away 6 is 1. So because we've made the right decision, we haven't done this over here, which wasn't helpful. Because we've gone and subtracted, we've now worked out that x equals 1. So we've worked out one of those coordinates. Going back to this slide, we've worked out that x equals 1, and our step 2 is going to be now to work out what the y value is. So that's our step 1 there in blue. We've worked out that x equals 1, and we were able to do that because we've eliminated y. Y has gone. Y was not eliminated over here. Now, step 2, okay, that's this bit here in purple. Now, what you do to start off with, you just take either of the equations that you were given in the question. It doesn't matter which one you take, but I've just chosen to take the top one. Okay, 3x plus y equals 7. And I've just copied that down again over here in purple. Now, we've just worked out here in blue that x is 1. So we can replace that x with 1 because we've worked it out. So 3x, that means 3 lots of x, that's 3 lots of 1. 3 lots of 1 is 3. So we can say that 3 plus y equals 7, therefore y must equal 4. So we've now worked out both the x value and the y value, and that was our goal. So x equals 1 and y equaling 4 is that coordinate where these two lines cross. So for this particular question, we needed to subtract one equation from the other. Now, why did we have to subtract? It was because we were honing in on these y values, right? They were the ones that had the same numerical value, 1y and 1y. So not worried about the x's, they've got different values. And because the signs were the same, in order for these y's to disappear, we had to subtract the second equation from the first. Adding would not have been any good. Now, let's say, for example, the question was like this. So this is example number 2. And I suggest what you do, guys, before you start doing the Hegarty maths exercise, perhaps you just wait for this video to upload and just copy down these examples. I mean, if you feel you're totally on top of it, you don't need to do that. But if you're still feeling a little bit hazy about it, I would suggest you just repeat this video several times, copying down this example before you start launching into that Hegarty exercise. So let's go and say here that we go and choose to add the two equations together. Okay, so I'm going to see what happens when I add the equations together. So 2x plus x is 3x. Now, y added together with minus y is the same thing as y take away y. We're adding together or taking away y. So we've got y added together with minus y. That's 0, and that's what we want. We've got rid of the y's. So by adding the equations on this occasion, the y's have disappeared. Now, why have they disappeared? It's because if you add them, when the signs are different, that's what makes it disappear. Okay, so question number 1, when the signs were the same, it made sense to take away because that's what got rid of the y's. However, with this question, when the signs are different, you've got to make the decision to add the equation together to have the desired effect of eliminating either the x's or the y's. So going back to adding them together, 2x plus x is 3x. Y added together with minus y is a big fat nothing. Excellent. And 21 add 6 is 27. So we've eliminated y, so we know that 3 lots of x equals 27. So we can now solve this. 3x equals 27. So divide both sides by 3, and we've worked out that x equals 9. Now, what do we then have to do? We've got to work out the y value. Okay, this is our step 2 here in black. Okay, now it doesn't matter which of the original equations you take. Okay, you could have taken the top one, or you could take the bottom one. I've just taken the bottom one on this occasion. So I say, right, whatever x is, I then take away y, and I get 6. Well, I've just worked out that x is 9. So 9 take away y is 6. So therefore y must be 3, because 9 take away 3 is 6. So for this question here, when we chose to add them, we get x equals 9. And this step 2, where you go back and you take one of the original equations, gave us y equaling 3. Now, I don't want to focus too much on this option number 2, but if we had made the wrong decision to subtract the equations, the y's would not have disappeared, because y take away negative y take away negative y here, and taking away a negative is the same as a positive, so we would have got y plus y equaling 2y, so the y's wouldn't have disappeared. So if we'd made the incorrect decision for this question to take away, it would not have achieved our desired result of getting rid of either x or y. So the key bit is, why on question 1 did we take away them equations? Because that's what made the y disappear. When you've got the same sign on the variable that you're trying to get rid of, you make the decision to take away. But where you've the variable that you're trying to get rid of, the y on this occasion, when the signs are different, the decision you make to eliminate the y is to add the equations together. So, pretty complicated, and it's not an ideal topic for us to be doing remotely, but we are where we are. That's the next thing on the scheme of work. So what I want you to do once this video is finished is to go over to Hegarty Maths and have a go at the questions in number 191. Okay, I have set it up as a task for you to do on Hegarty, but as you know, Hegarty has been very slow to load up. So if it's not already waiting for you to do 191, please just go and put 191 into the search box at the top, and it will come up saying Simultaneous Equations by Elimination 2, and click on it and watch the video if you want, but really I want you to launch into the quiz and get the questions in the quiz done. Okay, so give it your best shot and just see how you get on. So here's an example of one of the questions in the quiz. So I've made the decision to take away, okay, because I've got my 2x and a 2x, so it's the x's which is going to disappear on this occasion, and I'm taking away because these are both positive 2x's. So when I take away the bottom equation from the top, 2x take away 2x is nothing. Excellent. 2y take away y is 1y, so y, and 6 take away 5 is 1. So I've worked out that y equals 1. Now don't forget, you've then got to go and work out the other one, okay? So you've got to go and work out what x is. So you take either of the two equations, it doesn't matter which one, okay? Oh, I've made a mistake here. I've said I took the bottom one. I actually took the top one, didn't I? Sorry. So ignore that bit in green. That bit in green should be on the top one there. I've taken the top one, 2x plus 2y equals 6. I've just worked out that y equals 1. So I can go and replace this 1 over here, this y over here with 1. So 2x plus 2 lots of 1 equals 6. 2 lots of 1 is 2. So 2x plus 2 equals 6. Take away 2 from both sides. 2x equals 4. So y equals 2. Okay. So x equals 2. All right. 2x plus 2 equals 6. Take away 2 from both sides. 2x equals 4. So x equals 2. So our final answer is x equaling 2 and y equaling 1. Now, these are not easy, so don't get disheartened if the first time you start doing the quiz on Hegarty, you don't score a great mark, okay? I won't just go and rush to copy across the first mark you get. I will give you a bit of time because you may need to go back and try the quiz a number of times before you get a mark you're happy with, okay? I've said before, and it was particularly applicable for that one where we were estimating the mean from group data. If you can go and upload your workings, it gives me a chance to go and improve your mark, because Hegarty just marks it right or wrong. So with that previous one, you could have spent ages getting it all pretty much right, that when you were working out the estimating the mean from those tables, remember? But if you just at the very last moment went and got it wrong because you got it wrong to the wrong decimal place or something, it doesn't take account of all your wonderful workings. It just marks it wrong. And there was only 3 questions, so it was dead easy to get 0 out of 3. And that you may find that's the same with these. If you're not scoring great marks, if you can upload your workings onto Teams through the class notebook and through the homework option, if you can upload it onto Teams, it gives me an opportunity to improve your mark from the Hegarty mark before I go and write it into my remote mark book. Okay, so well done, guys. Thanks so much for so many of you tuning into it live. I will, of course, go and upload the video onto YouTube, and of course, it automatically uploads onto the Teams posts page. So I hope you have a nice long bank holiday weekend when it finally arrives. And so take care, guys.